Okay friends, today I am going to teach you about electrostatics. See here, now the question is, what is the meaning of electrostatics? See here, the word electro means charge. The word electro means charge and static means at rest. Keep in mind, what is the meaning of electro? Electro means charge, statics means at rest. See here, study of charge at rest is called electrostatics. Got the idea? What is the meaning of electrostatics? Simply, electrostatics means study of charge at rest. That's why we define the electrostatics like it is a branch of physics which deals with the study of charge at rest. Now, the concept of electrostatics was first time given by a scientist, William Gilbert. It is the name of the scientist who introduced the concept of electrostatics. Already you know, my dear friends, that is electrostatics means study of charge at rest. Okay. Now, what is the meaning of charge? What is the meaning of electric charge? See here, electric charge. Let us study about electric charge. Electric charge, simply charge. What is the meaning of electric charge? If you want to know electric charge, you must have knowledge about gravitation force. That's how it is. See here. You know that when you throw anything, then what happens? Suddenly it falls down. Why it falls down? Because of gravitation force of attraction. You must keep in mind, in the previous year you have already studied that gravitation force develops between those two bodies which are having finite mass. See here, for example, if this is a pen, it is having finite mass. If I throw like this, suddenly it falls down. Why it falls down? Because it's having finite mass. That's why Earth is going to attract it. Earth is also having finite mass. And you know that in this way, the gravitation force develops between those two bodies which are having finite mass. But if you consider the soothe particles, you see Curvature, ನೀವು ದೇವ್ರ ಮುಂದೆ ಕರ್ಪೂರ ಹಚ್ತೀರಿ, ಆ ಕರ್ಪೂರ ಹಚ್ಚಿದಾಗ ಕಾರ್ಬನ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಕಾಡಿಗೆ ಅಂತೆಲ್ಲ ಅದು ಮೇಲೆ ತೇಲ್ತಾ ಹೋಗ್ತದ. ಈಗ ನಮ್ಮ ಕ್ವಶನ್ ಏನಪ್ಪಾ ಅಂದ್ರೆ, ಇಷ್ಟು ದೊಡ್ಡ ಪೆನ್ ಅನ್ನ ಗ್ರಾವಿಟೇಷನ್ ಫೋರ್ಸ್ ತನ್ನ ಹತ್ರ ಅಟ್ರಾಕ್ಟ್ ಮಾಡ್ತದ, ಆದ್ರೆ ಆ ಸೂತ್ ಪಾರ್ಟಿಕಲ್ ಕಾಡಿಗೆಯನ್ನ ತನ್ನ ಹತ್ರ ಅಟ್ರಾಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಳೋದಿಲ್ಲ. Why? Because the best answer is the soothe particle do not possess mass. Already you know that gravitation force develops between those two bodies which are having finite mass. But in case of soothe particles do not possess any mass. That's why they are not attracted by the earth. That's why avu mele teli hogtava. Getting the idea? In this way, gravitation force develops only between those two bodies which are having finite mass. If the body do not possess mass, then the gravitational force will not develop. That's why we say that mass is the property which is responsible for gravitation force. See here, come to the point, that is electric charge. See here, I will consider one proton and one electron. When one proton and one electron are brought closer, they are found to attract each other. They are found to attract each other. Attract each other. Why they are found to attract each other? Don't say the charge on proton is positive, the charge on electron is negative. Don't say like this, because in those days, no one can know. Nobody can know. There are two types of charges. They are positive and negative. At the time of William Gilbert, nobody know there are two types of charges, positive and negative. So don't say like this. Here, when one proton and one electron are brought closer, they are found to attract each other. See here, according to Newton, the two bodies are going to attract when they are possessing finite mass. Here, one proton and one electron, when one proton and one electron are brought closer, they are found to attract each other. William Gilbert called this attractive force as gravitational force. Why he called this attractive force as gravitational force? Because proton and electron are having finite mass. That's why he called this force, this attractive force, as gravitational force. Okay? Because proton is having finite mass, electron is also having finite mass. Because of those masses, this attractive force developed between them is considered as gravitational force. But if you consider two protons or two electrons, they are found to attract each other, but it will not happen like this. But when two protons or two electrons are brought closer, they are found to repel each other. They start repelling. Why they are going to repel? See here. You see, when one proton and one electron are brought closer, they are found to attract each other. And this attractive force is called as gravitational force because proton and electron are having finite mass. But when two protons or two electrons are brought closer, they are found to repel each other even they are possessing mass. Here proton having mass, electron having mass. Even they are possessing mass, they are found to attract each other, but they are not attracting, they are repelling each other. Why it is happening like this? Why it is happening like this? This is the question. Keep in mind, here proton, electron, they are having mass. If they possess mass, gravitational force also is there, attractive force also is there, but they are repelling. This means what? Repulsive force is more in magnitude compared to gravitational force. They are possessing mass, gravitational force is there, attractive force is there, but in minimum amount. But here the question is, why repulsive force is happening between two protons and two electrons? This is our question. See here attractive force is there. Why this attractive force is there? Because the property of mass, both are having mass. Here, even they are possessing mass, but repulsive force is there. This means what? For this repulsive force, something is there which is responsible for this repulsive force, and that something which is responsible for repulsive force between two protons and two electrons is called what? Charge. Got the idea? And the repulsive force between two protons and two electrons, this repulsive force is called electrical force. Okay? For this electrical force, some property is responsible, and that property is called what? Charge. That's why charge is defined as it is the property present between two protons and two electrons which produces electrical force, repulsive force between them. Got the idea? Now, what is the meaning of electric charge? Electric charge means it is the property between two protons or two electrons which is responsible for repulsive force, electrical force between two protons and two electrons. See here mass property already is there. Along with this mass property, one more property is there. That one more property is called what? Charge. And that property is responsible for repulsive force between two protons and two electrons. Getting the idea? That's why we define the electric charge as two protons or two electrons possess some property other than mass which is responsible for repulsive force between them, and that property is called as electric charge. Getting the idea? Okay. Now you know that the meaning of electric charge. Now this electric charge is possessing some properties. What are the properties of electric charge? Properties of charge. What are the properties of electric charge? See here, the first property is there are two types of charges. They are positive and negative. There are two types of charges. They are positive and negative. And second property is like charges, that is plus or plus minus, repel each other, and unlike charges, that is plus and minus attract each other. What is the first property? There are two types of charges, they are positive and negative. And second property is like charges, that is minus. Like charges plus minus. Like charges repel each other, and unlike charges, that is plus and minus, attract each other. And third property is charge is conserved. Charge is conserved. What is the meaning of charge is conserved? This is very important. For 1 marks, it's going to be asked. What is the meaning of charge is conserved? Here, I will give one example. See, this is a pen, but consider it as glass rod, and this is as silk. Here, what is the charge on this glass rod? 0. What is the charge on this silk? 0. Okay. Now both are possessing 0 charge. Okay. Now when this glass rod and silk are rubbed together, what happens? After rubbing, this glass rod is going to lose its electrons. Thus, by losing electrons, this glass rod becomes positively charged. And whatever the electrons lost by the glass rod, they were accepted by silk. In this way, by gaining the electrons, the silk becomes negatively charged. Keep it in mind, before rubbing, what is the charge on this glass rod? 0. What is the charge on this silk? This is also 0. But after rubbing, the glass rod is going to lose its electrons, that's why it becomes positively charged. And the silk is going to accept the electrons, that's why it becomes negatively charged. In this way, after rubbing, both are charged. Here, in this phenomenon, charges are not created, they are only transferred. That is the meaning of charge is conserved. That is, charge is conserved. This means neither charge can be created nor they can be destroyed, but they can be transferred from one body to another body. Here, glass rod and silk both are rubbed together. After rubbing, this becomes positively charged, this becomes negatively charged. Here, charges are not created, charges are transferred only. This is the meaning of charge is conserved. Okay. Now, the fourth property is charge is quantized. Charge is quantized. Charge is quantized. What is the meaning of charge is quantized? I have already told in the classes, that is, if Q is the charge on the body, N is the number of electrons added or removed, and E is the charge on each electron. Okay, now Q is equal to N into E represents charge is quantized. That means charge is quantized. This means the charge on any body is always equal to integral multiple of charge on each electron. If you add the electrons, you have to take negative sign. If you remove the electrons, you have to take positive sign. In this way, charge is quantized is given by Q is equal to plus or minus N into E. Here Q means charge on the body, N means number of electrons added or removed, E means charge on each electron, and charge on each electron is minus 1.6 into 10 raised to minus 19 coulomb. Okay, what do you mean by charge is quantized? This question is also going to be asked in 1 mark questions. That is, charge is quantized. This means the charge on any body is always equal to integral multiple of charge on each electron. Here Q is the charge on the body, N is number of electrons added or removed, E is the charge on each electron. This is the meaning of charge is quantized. Now, fifth property, that is fifth property, charge is unaffected by motion. Charge is unaffected by motion. That is, charge of a body at rest is always equal to charge of a body in motion. Charge is unaffected by motion. That is, consider this is a body having some amount of charge. Okay, if this body is set into motion, then it will not losing its charge. That is the meaning of charge is unaffected by motion. In later class I will explain in detail. Fifth property is charge is unaffected by motion. That is, charge at rest is always equal to charge in motion. Okay, and also you must remember that the last property, charges exist only on the outer surface of the conductor. That is, if this is a spherical conductor, if you give some amount of charge to this, then charge is going to accumulate only on the outer surface of the conductor, and no charge is enclosed by the inner surface of the conductor. These are the 6 important characteristic properties of the charge. If they will ask 2 mass or 1 mass, they are going to ask mention any 2 or 3 properties of electric charge, then you should write this one, and this one. Okay, these are very important characteristic properties of the electric charge. If they will ask for 3 mass, mention any 3 properties of electric charge, then you should write charge is conserved, charge is quantized, and charges exist only on the outer surface of the conductor. Getting the idea? Getting the idea? Now let me to repeat again. What is the meaning of electrostatics? It is the branch of physics which deals with the study of charge at rest. The concept of electrostatics was first time given by a scientist, William Gilbert. What is the meaning of electric charge? 2 protons or 2 electrons possess some property other than mass which is responsible for electrical force between them, and that property is called as electric charge. What are the properties of electric charge? There are 2 types of charges. They are positive and negative. Like charges, that is plus plus or minus minus, repel each other, and unlike charges attract each other. Charge is conserved. This means neither charge can be created nor it can be destroyed, but it can be transferred from one body to another body. Charge is quantized. This means the charge on any body is always equal to integral multiple of charge on each electron. The charge is unaffected by motion, and charges exist only on the outer surface of the conductor. Okay, make this perfect, and I will ask questions on these concepts. Okay, thank you very much. Dear friends, already you have studied what is the meaning of electric charge and what are the different properties of electric charge. Today I am going to explain electrification. Dear students, today I am going to ask some basic questions to you. Okay? Whatever the substances present around you, like chair, desk, pen, book, etc., does they possess a charge? Then what will be your answer? Yes, students, your answer will be definitely no. But what is the real answer? Okay, let me to explain. Dear students, already you have studied that all substances are made up of atoms, and each atom is made up of proton, electron and neutron. And also you know that the charge on proton is plus 1.6 into 10 raised to minus 19 coulomb, and the charge on electron is minus 1.6 into 10 raised to minus 19 coulomb. And the only thing is the magnitude of charge of proton and electron is same, but only sign is going to be changed. The charge on electron is taken as negative and the charge on proton is taken as positive, but magnitude is same, that is 1.6 into 10 raised to minus 19 coulomb. And also one more thing, you know that neutrons are electrically neutral. From this information it is clear that in all substances protons, electrons, that is charges, are present. Okay, now tell me, all substances present around you possess charge? I know, my dear students, now your answer will be yes. Oh, Maunesh sir, you are confusing us. A little before you told no, but now you are telling yes. Is there any confusion? Yes, totally, now you are in confusion. Okay, my dear students, I know that your curiosity has been reached its peak level. Now let me to explain. The best answer is all substances neither possess positive charge nor possess negative charge, but their net charge is going to be 0. Why? This is because they are containing equal number of protons and electrons. From this discussion, it is clear that in nature, whatever the substances are possessing zero charge. That means their net charge is going to be considered zero. If the net charge of the bodies is zero, and such bodies are known as neutral bodies. Getting the idea? From this discussion, we came to the conclusion that whatever the substances in nature, chair, book, pen, scale, and you also, all these substances are possessing equal number of protons and electrons, hence their net charge becomes zero, and the bodies whose net charge is zero, such bodies are considered as neutral bodies. That means in nature, whatever the substances are considered as neutral bodies. That means they possess equal number of protons and neutrons such that their net charge becomes zero. Now, see here, when the electrons from these neutral bodies are removed, what happens? You know that the charge on electron is negative, the charge on proton is positive. If you remove the electrons from the neutral body, then what happens? Negative potential gradually decreases, positive potential increases. This means, that's why I told you, whenever a body, a neutral body, loses its electrons, it becomes positively charged. And the body, when it gains the electrons, that means when electrons are added to the neutral body, then negative potential gradually increases. That's why it becomes negatively charged. Keep in mind. See here, in this way, the body which gains the electrons becomes negatively charged because the charge on electron is negative. And the body which loses the electrons, it becomes positively charged because it is going to lose its electrons. Okay. Now let me to explain what is electrification. Already told you, when you remove the electrons from a body, it becomes positively charged. When you add the electrons to a body, it becomes negatively charged. In this way, just by adding or removing the electrons from a body, the body is going to be charged. This process is known as electrification. Now came to the idea. Now tell me, what is the meaning of electrification? Electrification means the process of adding or removing the electrons from a body to charge that body is called as electrification. If you remove the electrons from a body, then the body becomes positively charged. If you add the electrons to a body, the body becomes negatively charged. In this way, just by adding or removing the electrons from a body, we can charge the body, and this phenomenon is known as electrification or charging. And also you must remember, we can charge any body, we can charge the neutral bodies by these three methods. That is, charging by friction method, charging by induction method, and charging by conduction method. By these three methods, we are going to charge the bodies, charge the neutral bodies. Now let us study what you mean by charging by friction. See here, I have already told you in the previous class, when glass rod and silk are rubbed together, what happens? By losing electrons, glass rod becomes positively charged. By gaining electrons, silk becomes negatively charged. In this way, when two suitable substances are rubbed together, one body becomes positively charged by losing the electrons and other body negatively charged by gaining the electrons. This method of charging is called as charging by friction. Okay. Now let me to explain what you mean by charging by induction. What is the meaning of charging by induction? See here there is some diagram is there. What it shows? See here, this is a spherical conductor and its name is capital A. And this spherical conductor is mounted on a insulated stand. See here 1, 2, 3, 4. 4 positive charges are there. 1, 2, 3, 4. 4 negative charges are there. This conductor is containing 4 positive charges and 4 negative charges. Then what is the net charge on this conductor? 0. Hence this conductor A is considered as neutral body because it is possessing charge, but equal number of protons and equal number of electrons are there. That's why net charge of this body becomes 0. Hence it is our neutral body. Conductor A is a neutral body. Okay. Now in the figure B, you observe that here negatively charged rod is brought near the neutral conductor A. When a negatively charged rod is brought near the conductor A, you know that like charges repel each other and unlike charges attract each other. That's why whatever the positive charge is present in the conductor A get gathered near this end, and whatever the negative charges gets repelled and collected at the farther end. In this way, negative charges are collected here and positive charges collected here because of the properties of charge. Like charges repel each other, unlike charges attract each other. When negatively charged rod is brought near the conductor A, these negative charges attract the positive charges and repel the negative charges. That's why positive charges are collected here and negative charges are collected here at the farther end. Now in the figure C, what you are observing, when the farther end is earthed, what happens? Whatever the electrons collected here, they are moving towards the earth because we have earthed here. That's why excess electrons are moving towards the earth. And after that, you may observe in figure D, what you are observing, all electrons are earthed and only positive charges are present in the conductor A. In figure C, what you have done, in figure E, what you have done, when this negatively charged rod is removed, then these positive charges equally distribute over outer surface of the conductor. Here charge is not equal to 0. But before bringing the negatively charged rod, what is the charge on the conductor A? 0. But after bringing the negatively charged rod, what is the charge on the conductor A? Not equal to 0. In this way, just by bringing the charged body close to the neutral body, we can charge the neutral body also. This method of charging is called what? Charging by induction. Here what we have done, before bringing the charged body, what is the charge on the conductor A? 0. But when you bring the charged body near the conductor A, this neutral conductor A is also going to be charged like this. This method of charging is called what? Charging by induction. Now let me to tell the definition. What do you mean by charging by induction? Charging by induction, it is the process of charging a neutral conductor. How? By bringing the charged body close to it but not in contact with it. This is the meaning of charging by induction. What is charging by induction? Charging by induction, it is the process of charging a neutral conductor by bringing a charged body close to it but not in contact with it. This is the meaning of charging by induction. Now, third method is charging by conduction. What do you mean by charging by conduction? See here, I will consider one more neutral spherical conductor here, which is mounted on the insulated stand. Here also it is containing equal number of protons and electrons. That's why net charge is 0. Hence it is our neutral conductor. When a positively charged rod is brought in contact with the neutral conductor A, then just like liquids, charges also flow from higher concentration to lower concentration. That is, charged body to neutral body until equilibrium is reached. Here 1, 2, 3, 4, 5, 6, 7, 8. 8 positive charges are there. When you brought in contact with the neutral conductor, here 1, 2, 3, 4. Here also 1, 2, 3, 4. That is, equilibrium has been reached. Both are getting same charge. Charges flow from charged body to neutral body until both gain equal charge. Here also 4, here also 4. Now this is charged. Now after this, you just remove this charged body and these charges equally distribute over outer surface of the conductor A. In this way, just by bringing and make it contact with the neutral conductor A, then also this neutral conductor is going to be charged. In this way, when you brought the charged body in contact with the uncharged body, the uncharged body is going to be charged. This method of charging is called what? Charging by conduction. What do you mean by charging by conduction? Charging by conduction, it is the process of charging a neutral conductor by bringing a charged body in contact with it. This is the meaning of charging by conduction. In this way, we can charge any bodies by these three methods. Keep it in mind, what do you mean by electrification? The process of adding or removing the electrons from a body to charge the body is called as electrification or charging. A body can be charged by three methods. They are charging by friction, charging by induction, charging by conduction. What do you mean by charging by friction? When two suitable substances are rubbed together, one substance becomes positively charged by losing the electrons and another substance becomes negatively charged by gaining the electrons. What do you mean by charging by induction? Charging by induction is the process of charging a neutral conductor by bringing a charged body close to it but not in contact with it. What do you mean by charging by conduction? Charging by conduction is the process of charging a neutral conductor by bringing a charged body in contact with it. These are the three methods of charging. My dear students, today I am going to teach you about distribution of electric charge. See here, whenever any body is charged, then the charges are going to distribute over the outer surface of the conductor. Here you are observing two figures. First one is spherical conductor, second one is conical shaped conductor. When spherical conductor is charged, the charges distribute uniformly over the outer surface of the spherical conductor. But when conical shaped conductor is charged, the charges are not uniformly distributing, whereas only at sharp edges the concentration of charge, density of charge is found to be maximum. But at plane surface, concentration of charge, density of charge is very minimum. By this it is clear that the distribution of charge, that is density of charge, mainly depends upon shape of the conductor. Now the question is, why only in case of spherical conductor the charges are going to distribute uniformly? Why only at sharp edges the concentration of charge, density of charge is very maximum? This is our question. To understand this, we should know the relation density of charge, concentration of charge is inversely proportional to radius of curvature. According to this formula, according to this concept, this is happening. Now, what is the meaning of radius of curvature? What is the meaning of radius of curvature? Okay, let me to explain. See here, my dear students, here you are observing three edges. 1, 2, 3. Three edges are there. If you see this edge under the magnifying lens, then you may observe this figure. Okay. Basically, this is sharp edge. If you see this edge by your naked eye, it will appear very sharp. But when the same edge is observed under the magnifying lens, it looks like this. Okay. Here you are observing curve. This curve appears large only in magnifying lens, but actually it is not large as you are observing here. It is very small curve. But in magnifying lens, you are observing this curve. If you draw the circle along this curve, then the radius of this imaginary circle is called what? Radius of curvature. Keep in mind, at sharp points, at sharp edges, this curve is too small. Hence, radius of curvature of this curve is very small. That's why, according to this relation, concentration of charge is very maximum only at sharp points, because according to this relation, density of charge is inversely proportional to radius of curvature. This indicates that density of charge is more in a region of low radius of curvature. Density of charge is less in a region of high radius of curvature. Here at a sharp point, what is happening? Radius of curvature is very small. That's why density of charge is very maximum. But in case of spherical conductor, radius of curvature is uniform. That's why charges distribute uniformly over the outer surface of the spherical conductor only. In this way, distribution of charge mainly depends upon radius of curvature. Okay, this is the relation between density of charge and radius of curvature. Now, my dear student, let us study one more concept. Here you are observing this is a wire, this is a surface, this is a tube. The distribution of charge on the bodies like along a wire, over a surface and over a volume consists of enormous number of closely spaced point charges. This type of charge distribution is considered as continuous charge distribution. In such situations, we speak about linear charge density, surface charge density, volume charge density. Now, what is the meaning of these? See here, linear charge density is nothing but it is defined as the amount of charge per unit length of the conductor, and its SI unit is coulomb per meter. Surface charge density is defined as the amount of charge per unit area of the conductor, and its SI unit is coulomb per square meter. Volume charge density is defined as the amount of charge per unit volume of the conductor, and its SI unit is coulomb per cubic meter. Okay friends, got the idea? So today I am going to teach about Coulomb's inverse square law. My dear students, here you are observing two charges are there, plus Q1 and plus Q2. As you know, these are like charges. This is also plus, this is also plus. That's why they are going to repel each other. That is, between these two like charges, repulsive force is going to happen. Okay? In the same way, here plus Q1 and minus Q2 are there. The distance between them is R. Here it is plus and minus. That is, these are unlike charges. That's why here attractive force develops. See here, the repulsive force present between these two static charges and the attractive force present between these two static charges is known as electrostatic force. That means electrostatic force may be repulsive or attractive. It depends upon the nature of the two charges. Here the like charges are there. That's why the electrostatic force is repulsive. Here unlike charges are there. That's why the electrostatic force is attractive. Now the question is, what is the magnitude of this electrostatic force? That is our question. We know that in between like charges, repulsive force is there. In between unlike charges, attractive force is there. And these repulsive and attractive forces are known as electrostatic force. Now, what is the magnitude of this one? We don't know this. See here, to calculate, to find the magnitude of the electrostatic force present between two static charges, a scientist Coulomb proposed a law. That a law is called Coulomb's inverse square law. Now let us study what it states. Here consider two charges Q1 and Q2 which are separated by a distance R. Okay. Now the electrostatic force F is a electrostatic force. Q1 and Q2, these are the magnitude of the two static charges, and R is the distance between the two static charges. Then what Coulomb's inverse square law states? Coulomb's inverse square law states that the electrostatic force acting between two static charges is directly proportional to product of magnitude of the two charges and inversely proportional to square of the distance between them. This is Coulomb's inverse square law. Here, according to Coulomb's inverse square law, F is directly proportional to Q1 into Q2, called it as equation 1. F is inversely proportional to square of the distance between the two charges, called it as equation number 2. From 1 and 2 we get F is directly proportional to Q1 into Q2 upon R square. Here alpha is called proportionality constant and it is also known as Coulomb constant and it is denoted by small letter k. Hence F is equal to k into Q1 into Q2 divided by R square. This is the expression for Coulomb's inverse square law. My dear friends, it is very necessary to study about Coulomb's constant because Coulomb's constant play an important role in calculation. See here, in SI system, the value of K is equal to 1 divided by 4 pi epsilon. Now the question is, what is the meaning of epsilon? Epsilon means it is the measure of a medium present between the two static charges. What is epsilon? Epsilon means it is the measure of a medium present between two charges. See here, in between Q1 and Q2, there may be a free space or there may be a medium. Okay. See here, if free space is present between Q1 and Q2 and that free space has some constant value and that constant value is called what? Permittivity of free space and it is denoted by epsilon naught. And what is that constant value? Epsilon naught is equal to 8.854 into 10 raised to minus 12 Coulomb square per Newton meter square. This is the constant value given to the free space present between Q1 and Q2. And this constant value is called what? Permittivity of free space and it is denoted by epsilon naught. Now the question is why we should insert the medium between Q1 and Q2. See here, to change the electrostatic force between Q1 and Q2, we are going to insert a medium. Those mediums are known as dielectrics and those dielectrics are having constant values and those constant values are called relative permittivity or dielectric constants, which is denoted by epsilon r. Dielectric constants varies from one medium to another medium, but they are constant. In this way, epsilon is represented as epsilon naught into epsilon r. Getting the idea? This is the meaning of permittivity. Now, see here, in SI system, already you know that the value of epsilon naught is 8.854 into 10 raised to minus 12 Coulomb square per Newton meter square. Then, if the value of K is this much, then this equation 4 can be written as F is equal to 1 divided by 4 pi epsilon naught into epsilon r because epsilon value is epsilon naught into epsilon r and into Q1 into Q2 divided by r square. Call it as equation 5. If between Q1 and Q2 air medium is there, air is a kind of medium. For this medium, it is having some value, some constant value. That value is called what? Relative permittivity. Okay. And if when Q1 and Q2 are kept in air medium, for air medium relative permittivity is 1. That's why the equation 5 becomes what? F is equal to 1 divided by 4 pi epsilon naught. Here epsilon r value is 1. That's why only epsilon naught is there. Into Q1 into Q2 divided by r square. Okay, this is our standard equation. And also you must keep in mind, if you substitute the value of pi, that is 22 divided by 7, and epsilon naught value, that is this much. If you substitute the value of pi and epsilon naught, this term is approximately becoming 9 into 10 raised to 9 Newton meter square per coulomb square. Hence this equation becomes F is equal to 9 into 10 raised to 9 into Q1 into Q2 divided by R square. This is our standard formula. This is about Coulomb's inverse square law. Okay, got the idea? Okay, my dear friends, take the notes of this one and please make it perfect as early as possible. Okay friends, in this class now we are going to study what is the definition of one coulomb and what is the definition of relative permittivity or dielectric constant, and also we are going to study what is the superposition principle in electrostatics. Now let us study what is the definition of one coulomb. Definition of one coulomb, simply denoted as capital letter C. Okay. Now I will consider two charges here, that is Q1 and Q2. This is Q1 and this is Q2, and they are placed at a distance R in air medium. Okay. Now I have considered two charges Q1 and Q2 which are placed at a distance R and they are kept in air medium. Now electrostatic force between Q1 and Q2 is given by Coulomb's inverse square law, that is F is equal to K into Q1 into Q2 divided by R square, called as equation 1. Now here Q1 and Q2 are kept in air medium. That's why the value of Coulomb constant becomes 9 into 10 raised to 9 Newton meter square per coulomb square into Q1 into Q2 divided by R square, called as equation 2. If Q1 is 1 coulomb, that is Q1 is 1 coulomb, and Q2 is also 1 coulomb, Q2 is also 1 coulomb, and R is distance between Q1 and Q2, R is also 1 meter, it is 1 meter. Then equation 2 becomes what? Then equation 2 becomes F is equal to 9 into 10 raised to 9 into Q1 is 1, Q2 is 1 and R is 1, that is square. Therefore F is equal to 9 into 10 raised to 9 Newton. Then what it indicates? What it represents? It indicates that here Q1 and Q2 both are identical charges because both are 1 coulomb and they are kept at a distance 1 meter. Here Q1 is repelling the Q2. Q1 is 1 coulomb, Q2 is also 1 coulomb. Here Q1 is repelling the Q2 with a force F is equal to 9 into 10 raised to 9 Newton, which is kept at a distance 1 meter. Okay, this means 1 coulomb is that charge which when placed at a distance 1 meter from an identical charge then repels this identical charge with a force 9 into 10 raised to 9 Newton. This is the definition of 1 coulomb. Okay, what is 1 coulomb? 1 coulomb is that charge which when placed at a distance 1 meter from an identical charge then repels it with a force of 9 into 10 raised to 9 Newton. Okay, now come to the next point, that is what is the definition of relative permittivity or dielectric constant. My dear students, relative permittivity is also known as dielectric constant. Okay? Now let us study what is the definition of relative permittivity. See here, relative permittivity is denoted as epsilon r or capital letter K. If you write small letter k, that becomes Coulomb constant. If you write capital letter K, that becomes dielectric constant or relative permittivity. Both are same. Now let us study what is the definition of epsilon r or K. Okay. Now I will consider again two charges, that is, here it is Q1 and this is Q2. Okay. This is Q1 and this is Q2, and they are kept at a distance r in a air medium. Okay. Here I have considered two charges, Q1 and Q2. They are placed at a distance r and they are placed in a medium air. Okay. Air medium is there. Since they are kept in air medium, then electrostatic force between these two charges which are kept in air medium, Fa is equal to 1 divided by 4 pi epsilon naught into epsilon r into Q1 into Q2 divided by r square. Okay. Now Fa is equal to 1 divided by 4 pi epsilon naught, epsilon r, relative permittivity of air. For air, epsilon r is 1, hence its value becomes 1. Okay, into Q1 into Q2 divided by r square. Okay, called as equation 1. This is the electrostatic force between Q1 and Q2 which are kept in air medium at a distance r meter apart. Now I will consider same two charges, that is Q1 and Q2. I will consider same two charges Q1 and Q2, Q1 and Q2 at the same distance, that is r. But instead of air between Q1 and Q2, here some medium is there, whose relative permittivity is epsilon r. Now what is the electrostatic force between them? Now electrostatic force between the Q1 and Q2 in a medium, Fm is equal to 1 divided by 4 pi epsilon naught into epsilon r into Q1 into Q2 divided by r square, called as equation 2. Now dividing equation 1 by equation 2, we get what we get? We get epsilon r is equal to Fa divided by Fm. This is the definition of epsilon r. Okay. Now it is clear that epsilon r or relative permittivity or dielectric constant is defined as the ratio of force acting between two charges separated by a certain distance in air medium, that is Fa, to the force acting between same two charges separated by same distance but in a given medium, that is Fm. This is the definition of relative permittivity or dielectric constant. Epsilon r is equal to Fa divided by Fm. Now the next concept is superposition principle in electrostatics. My dear students, when a number of charges are present, when multiple charges are present and they are kept at a certain distance, then all the charges are exerting force on each other. Now our question is, what is the net force on one charge due to all other charges? This can be calculated by using a principle. That principle is called what? Superposition principle. That is superposition principle. Superposition principle. superposition principle. That is, when number of charges are present, when multiple charges are kept at certain distance, all the charges are exerting force on each other. What is the net force on one charge due to all other charges? This can be calculated by this principle. Now consider three charges here. I will consider three charges here. This one charge, this one is a charge, and this is also a charge. Okay, say this is Q1 charge, this is Q2, and this is Q3, and R12 is the distance between Q1 and Q2. R13 it is the distance between Q1 and Q3, and here this is origin. Here R1 is the distance between Q1 and origin O, and R2 is the distance between Q2 and O, and R3 is the distance between Q3 and O. Here three charges are present, Q1, Q2 and Q3, at a certain distance from the origin O. R12 it is the distance between Q1 and Q2. R13 it is the distance between Q1 and Q3. Now our question is, what is the net force on one charge? What is the net electrostatic force on one charge due to other two charges? Now let us calculate what is the net electrostatic force on Q1 due to Q2 and Q3. That we are going to calculate. Okay. Now let us find what is the electrostatic force on Q1 due to Q2 charge. Here Q2 is repelling the Q1 with a force how much? I will consider this force as vector F12. Vector F12 means what? This is the force exerted by Q1 due to Q2. Okay, see here. Force on Q1 due to Q2 is vector F12 is equal to K into Q1 into Q2 divided by R12 square into R12 cap. Here this is what R12 cap is the unit vector in the direction of Q2 to Q1. Okay, here F12 is acting in this direction because Q2 is repelling the Q1 because both are like charges. Okay, similarly force on Q1 due to Q3 is what? Vector F13 is equal to, it is acting in this direction, vector F13. Q2 is repelling Q1 in this direction because both are like charges. Vector F13 is equal to K into Q1 into Q1 into Q3 divided by R13 square into R13 cap. Here is the unit vector in the direction of Q3 to Q1, called as equation 2. Now net force on Q1 due to Q2 and Q3 is what? Vector F1 is equal to vector F12 plus vector F13. What it indicates? That is, net force on Q1 due to Q2 and Q3 is equal to vector sum of forces due to other two charges. This is the meaning of superposition principle. That is, according to superposition principle, when a number of charges are present at a certain distance apart, then the net electrostatic force on one charge is always equal to vector sum of forces due to all other charges. This is the meaning of superposition principle. That is net force on Q1 is equal to K is taken common, that is Q1 into Q2 divided by R12 square into R12 cap plus Q1 into Q3 divided by R13 square into R13 cap, okay, called as equation 3. So equation 4.